Hello and welcome to the fourth video in the series Educational Videos for Novice Java Programmers. Today will be our first look at semantic errors. We've already seen that syntax errors are mistakes in the code, which are often shown to us by the compiler. As the compiler shows us what these problems are and when the error occurs, it's normally easier to isolate and fix these issues. However, semantic errors are when the expected behavior of a program does not match the actual behavior of the program. The program would have been compiled without any errors, but still does not have the expected outcome. It can therefore be difficult to isolate the problem without compiler error messages to help us. So the main aim of this video is to show you how to avoid certain semantic errors and explain why they have the behavior that they do. This will be done by showing you two common semantic errors found amongst novice Java programmers, demonstrating the correct way to handle certain statements of code so that you can achieve the functionality that you're after. So the first semantic error that I wish to focus on will be the misunderstanding that novices have when using the comparison operator to compare strings. I will show you the correct way that this should be done and what the behavior will be when comparing strings incorrectly. After that, the second semantic error that we will look at is when a non-void method is called, but its return is not captured. What implications this can have, and what design decisions should be made when choosing to use void or non-void methods to handle functionality. So that's what we're going to look at in this video. So now let's move over to IntelliJ to have a look at the first one. So now it's time to have a look at the first semantic error that I wanted to talk about, and that was the misunderstanding that novices have when using the comparison operator to compare strings and sometimes not getting the expected behavior that they were after. So to start off with, I have three comparison tests here. The first one will be comparing two ints, the second one comparing two students, and the third one comparing two strings. So all of these should be true because here you can see both of these ints are 2, both of these students are taken from the controller, both of the same ID, and these two strings are these two objects just put to string. So if I run this, the first one is true because, like I say, the two ints were identical, and the second one is true because the object's the same. However, the third one did not print when comparing the two strings. Although, it can be seen here, if we print these out, the strings themselves, we can see that they are in fact identical. So they both have ID number 2, same name, same modules, etc. They are exactly the same. So how come when compared using the comparison operator, they didn't equal true? And this is because when using the comparison operator to compare two strings, it doesn't actually look at the contents of these strings. It in fact compares the memory location of the objects. And because these are two separate strings, they will be stored in two separate locations in memory. So therefore, in the eyes of this if statement, these two strings are not identical. When even though up till now we would want to compare their contents and therefore use this comparison operator. So that is why, although we received no errors from this, it would not produce the behavior that we are after. So the workaround for this, to compare strings, is to use this statement instead. So you can see here that we are calling this method equals on one of the string objects. Because obviously, as these strings are objects, there are many methods that we can take from them. And one of them here is this equals method. We can place another string here, and then it will actually compare the contents of the two strings, and therefore we can see this does print true. So the most important thing to take away from this is that whenever you want to compare two strings, it is always better to use this equals method. So then you'll always get the expected behavior that you're after. When comparing anything else, you can just use the comparison operator. But there is one important thing that I would like to show you, and that is here. Here we have two more strings, both of which say hello. And we've just seen how it's better to use this equals operator. But if I compare these two strings using the other comparison operator, we can see that this actually also prints to true. So how come it didn't work up here, but now it does work? And the reason is because these strings are hard-coded into this program. So IntelliJ very cleverly has realized that these strings are hard-coded and therefore determinable at compile time. So that way it can assume that when comparing them, you are looking at the contents and not their memory locations, because these are still two separate strings and therefore will still have two separate memory locations. But it assumes because these strings will never change, when comparing them, you'll mean their contents. Whereas up here, these strings are assigned using a toString method on an object which also hasn't been filled until this return statement is called. So therefore, this string won't be determined until the program has run and finished executing and finding out what these strings are. So it doesn't know what these strings are going to be, so it plays it safe essentially and assumes that you're just trying to compare the memory locations, when in fact the majority of the time you are trying to look at the contents. So that's an important thing to see, but it is better to always use this equals method to compare two strings. So that way you'll always get the behavior that you are expecting. So that's all I wanted to show you for that. So now we can move on to the next one. So the next semantic error that I wanted to talk about was when a return value is not captured or is possibly discarded when it is called. So just to clarify, there are two types of methods that you can call: a void method and a non-void method. Non-void methods are often also referred to as return methods or get methods. A void method simply does something. It just has some functionality that you want to perform on an object. So here you can see this print state method from the controller class is a void method, which means we just wanted to do something. And in this case, it will print out all of the staff, students, and modules in the controller class. So therefore, we can just go ahead and call it whenever we want, and it will go ahead and perform its functionality, like so. Whereas a non-void method will return something after it's finished. So we've seen this getStudent method before. So if we go ahead and have a look at it here, instead of void here, it says student, which means the result of this method will return either a student if its ID is in this collection, or it will return null. So whatever the functionality is, at the end it will still return something to where the method was originally called. So if we go ahead and call these 4 non-void methods here, if I comment out first, the program has executed this code. It has gone off, called the method, and returned its result here. But nothing has actually happened. Nothing has actually been stored locally. And that is the problem here of when you call a non-void method but not capturing its result. It's essentially the same as performing a maths problem but not writing down the answer afterwards. You're calling a method, you're using computational power to run this method but not keeping the answer that is produced for you. So when you're using a non-void method, it's important that you keep its answer. So here you can see that the result of this will return a student, a module, and a string. And as we've seen from the assignment operator, the thing on both sides has to be the same. So here we are going to store 2 students, a module, and a string into these variables here. So if we run that, we can still see nothing happens because we haven't asked it to do anything on these objects. But at least now you know that the result from these has been stored locally. And because they have been stored locally, you are then able to do something to these answers. You can then look at them, you can change them, manipulate them however you like. So if we print them out to have a look at what they are, you can see it has worked. You can see that it has gone off and found this second student, and you can see here it says null because there is not a student in the controller class with the ID number 4. Whereas if we didn't print these out or we didn't assign them, 1, this would be a waste of a method because it's not actually doing anything in terms of returning something, and we wouldn't know that this method would in fact not work because there is not a student with ID number 4. But because we've captured its return and we've inspected it by printing it out, we can see that one of them works and one of them doesn't. So that's the important thing to note here. So this is where the design decision comes in of whether you want to use a void method or a non-void method. If you simply want to do something to happen behind the scenes, some sort of functionality, use a void method. Whereas if you want to do something that has the result that you want to see or you want to manipulate further, then you decide to use a non-void method. But in doing so, you have to capture the result of the non-void method. Otherwise, there was no point in calling it anyway. You may as well just use a void method if you don't want to keep the result of it. So that's really what I wanted to look at today. So we've had a look at the first error, which was when to use the comparison operator and when to use the string object method equals, when you should use each one, and what happens when you use them incorrectly. And now we've just seen the second error, which was not capturing return values when calling a non-void method. So in the next video, it will be another look at some more common semantic problems found amongst novice Java programmers. But until then, thank you very much for watching.